In this video, I'm going to explain linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the observed data. It is a common technique used in data analysis and predictive modeling to make predictions or understand the relationship between variables. In similar linear regression, there is only one independent variable and one dependent variable, and the relationship between them is represented by a straight line. The equation for a simple linear regression model is y is equal to mx plus b, where y is the dependent variable, x is the independent variable, m is the slope of the line, and b is the intercept. In multiple linear regression, there are multiple independent variables, and the relationship between them and the dependent variable is represented by a plane or hyperplane. The equation for a multiple linear regression model is y is equal to b0 plus b1 x1 plus b2 x2 plus so on plus bn xn, where y is the dependent variable, x1, x2, so on xn are the independent variables, and b0, b1, b2, so on bn are the coefficients. So linear regression can be used for various purposes such as predicting sales based on advertising expenditure, understanding the relationship between customer satisfaction and product quality, or analyzing the impact of different factors on a particular outcome. It is a powerful tool that can provide valuable insights and help make informed decisions. The linear regression has various applications in different fields, including but not limited to, we'll see that a few applications. The first one is economics. Linear regression is used to study the relationship between different economic variables, such as the relationship between demand and price, or the relationship between investment and GDP, etc. Next is finance. Linear regression is used in finance to build models that help investors make informed decisions. For example, it can be used to predict stock prices based on past trends or to analyze the impact of different factors on portfolio returns. Healthcare. Linear regression is used in healthcare to study the relationship between different medical variables, such as the relationship between a patient's age and the likelihood of a certain disease, or the relationship between the dosage of a drug and its effectiveness. Next, marketing. Linear regression is used in marketing to understand the relationship between different marketing variables, such as the relationship between advertising, expenditure, and sales. The other relationship between customer satisfaction and product quality. Sports. The linear regression is used in sports to predict the outcome of games and to analyze the impact of different factors on performance, such as the relationship between a team's winning percentage and the number of home runs they hit. So overall, the linear regression is a powerful tool that has applications in a wide range of fields, and it can help provide valuable insights, make informed decisions based on data. So the equation for a simple linear regression model is the general equation y is equal to b naught plus b1x plus epsilon. B naught is the intercept of the line, and b1 is the slope of the line, and epsilon is the error term. Now let us see that say a few problems. The problem 1, a Visuada car dealership wants to predict the price of a car based on its age. They collect data on the age of a sample of cars in years and their selling price in lakhs. The data is as follows. That age is given, the price is given. If 1 year old, it's a 20 lakhs. 2 years old, 18 lakhs. 3 years old, 16 lakhs. 4 years old car, 13 lakhs. 5 years old car, 10 lakhs. So like that, the age and the price is given. Now uh, we will use the least squares method to find the equation of the line of to be best fit for the given condition. So the equation for a simple linear regression model is y is equal to b naught plus b1 x. How we can calculate the beta 1? That is a sigma xi minus x bar into yi minus y bar by sigma xi minus x bar whole square. This is the formula we can use to find out the beta 1. First, let us find out the x bar. So the number of years are given 1, 2, 3, 4, 5. That take the average of these 5. So that is 3. Similarly, find out the average of the cost of each year. So 1 year 20 lakhs, second year 18 lakhs, third year 16 lakhs, 4 years 13 lakhs, 5 years 10 lakhs. So total sum divided by 5, it's obtained 15.4 lakhs. That is average value. So now the beta 1, you can substitute in the above formula, you can obtain beta 1. Calculate that beta 1 is minus 2.5. So once beta 1 is known, then we can calculate the intercept of the line using the formula beta naught, that is equal to y bar minus beta 1 x bar. So beta naught is equal to the y bar, that is 15.4, and beta 1 is minus 2.5, minus in minus plus 2.5 into x bar is 3. From this you can obtain beta naught, that is 22.9. That substitute beta naught and beta 1 in that equation, then you can obtain the equation of the line for the best fit, that is y is equal to beta naught plus beta 1 x. So the actual solution is y is equal to 22.9 minus 2.5 into x. So at any value, okay, at any value x, suppose if you want to substitute, I want for 8 years old, so then you can substitute 8 in x, then you can obtain the y value. So likewise, once that equation is set up, so you have to find out that at particular x, what is the y value can determine. So likewise, we can build the simple linear regression model. Now let us see that next is multiple regression model. Now let us see that one problem, how we can going to handle, build a multiple regression model that can predict the price of a house based on several features such as size of the house, number of bedrooms, and the location of the house. We have collected data on these features for a simple houses in the city and also recorded the actual sale price of each house. Actual sale price of each house. So now this is the data is given, that house size square feet, number of bedrooms, location 1 to 10, and sale price in lakh. Okay. If it is 1500 square feet and 3 bedrooms, the location is at 8, then it's having the 2,50,000 sale price. Likewise, the given square feet 2000, 1800, 2500, to like that, number of bedrooms and location. Based on these factors, you can decide the sale price in lakhs. Sale price in lakhs. So to build a multiple linear regression model for this data, we would first need to define the predictor variables, which in this case are the house size, number of bedrooms, and location. So we would then fit a linear regression model to the data using these predictors with the sale price as the response variable. So the model would have the following form: sale price in terms of lakhs, that is equal to beta naught plus beta 1 into house size in square feet plus beta 2 into number of bedrooms plus beta 3 into location, that 1 to 10, plus, and if any error is there, that epsilon also you can add. This is the model would have the following form. So where beta naught is the intercept term, and beta 1, beta 2 and beta 3 are the coefficients for each predictor variable, and epsilon is the error term. So once we have fit the model to the data, we can use it to make predictions about the sale price of new houses based on their futures. For example, if we had a new house with a size of 2300 square feet, 3 bedrooms and a location score of 7, we would plug these values into the model and obtain a predicted sale price based on the regression equation. Okay. So likewise, we have to develop the required model for predicting the future values. I hope everyone understand what is the linear regression. Okay, that is in the simple and multiple linear regression.